So this is taking a look at the AQA GCSE Chemistry Dual Award. As I continue making these videos, I will add the separate science videos as extra sections at the end. But we're going to start with the first fundamental chapter, part 1, atomic structure. This is going to be in 8 separate parts, so they're going to be quite short videos. I'm going to recommend that you pause and have a go at the activities when you look at them. And then you get a chance to review, see what's gone well, and see what you need to work on. So let's begin with the objectives for this particular video. Being able to define the term element, understanding the basic structure of the periodic table, knowing the structure of an atom, and recognising that elements have their own symbols, and a little bit about where they come from. But let's start off with the first task. We have got some keywords and some definitions. So let's have a go at matching these up. And it's worth pointing out that when you are looking at these definitions, you need to be able to remember them. And that's partly about picking up marks for reciting them, but it's about understanding them as well, so that you can use them effectively in the right circumstances. So let's start with the atom. Well, the definition of an atom is that it's the smallest part of an element that will have all of its chemical properties. If I take a piece of lithium and I cut it up and cut it up and cut it up, I will eventually end up with a lithium atom. And every single lithium atom that I look at will be identical. If I move on to elements, well, elements are made up of only one type of atom. I go back to that same circumstance where I can break my lithium, an element, down again and again and again, and every single atom that I find there will be identical. And that then takes us to compound and mixture. There is a very important distinction to be made here. The compound is a substance made up of 2 or more types of atoms chemically joined in fixed proportions. Think about things like water. Water is H2O, 2 hydrogen atoms and 1 oxygen atom. If we look at mixture, however, it's more than one type of atom or compound mixed but not chemically joined together. The fundamental difference that lies between something being a mixture and something being a compound is that in a compound, they are chemically joined. In a mixture, they are not chemically joined. Good example of a mixture is the air around us. We've got molecules of nitrogen, molecules of oxygen, we've got molecules of carbon dioxide, we've got atoms of argon, and they're all mixed up together, but they're not combined with one another. Okay, let's move on, have a go at this task. And this is just to get you thinking about the bigger picture within this topic. We're going to dig down a little bit on some of the points that are being raised here in future videos. But 1,000 elements? Absolutely not. That's false. There are 100 and something elements. Few more have been discovered relatively recently, but there won't be many more now. But everything that exists on the planet is made up of combinations of those atoms. So absolutely, all substances are made of atoms. Sometimes those atoms are within compounds, but they're all the building blocks that everything is built from. Compounds listed on the periodic table, that one is false. The periodic table gives us information about all of the elements that exist. Compounds are made by combining elements together, as we'll see in more detail later on within this course. Sulfur is a compound? Absolutely not. Sulfur is on the periodic table. It's on the right-hand side. Its symbol is S. If you have a periodic table, you can find it. And if it's on there, that means it is an element. And then it asks, is sodium an element? Well, that one's true as well. You'll find sodium on the left-hand side of the periodic table with the symbol Na. So that is definitely an element. And then we've got an element contains only one type of atom. Now that one is true, and we discussed it on the previous activity. And then we've got this question down at the bottom. Why do we use such a wide variety of techniques to give symbols to elements? Well, if you look at some of them, we have got things like hydrogen has H, but I couldn't give helium H because that's already been used. So I needed to, in the case of helium, we used the first and the second letter. You will notice first letter always a capital, second lowercase. There's other elements that begin with H. And in the case of HF, we have hafnium. So that's taking not the first and the second letter, but the first and one other letter. And if you look at alternative ones on here, I've got AU, which is gold, absolutely no link to the name. AG, absolutely no link to the name that we know. And PB, absolutely no link to the name lead. There is a history that's led to these names, though. And as an example, lead, PB, comes from an old name for lead, which is plumbum. And if you think about lead used to be used for water pipes, it actually makes very much sense that when people get their water pipes fixed, we use a plumber. The name of that tradesman comes from the name that used to be used for lead that has inspired the symbol. Okay, we've got another task for you here. Describing in words what the diagram tells us about atoms. And I'm going to be absolutely honest, it does not tell us much. We are going to look at this in a lot more detail further on in the course, but we can see there is a nucleus at the centre, and we can see that there is something called electrons which are outside the nucleus. Now, I've highlighted the word electron because that's one of the 3 subatomic particles that you are going to get to know very, very well. Where else do we use the word nucleus, and what does it mean? Well, in biology, we talk about cells having nuclei, and that's the control centre of the cell. And I've just highlighted those words because that might help you to remember that key detail, that the nucleus sits at the centre, at the heart of the atom. And in later videos, we're going to find out what's in that nucleus. Okay, for the final task, you might not be able to do this one, but you can certainly think about where it would go. Where is the divide between metals and non-metals? You will be expected to recognise where this is so that you can identify things as metals or non-metals. So now you've had a chance to think about it, hopefully you've paused as you've gone. I will tell you that the divide starts above aluminium and comes down in steps. Everything to the right of that is non-metals, so is hydrogen. Hydrogen is a non-metal, so it goes over with this side. Everything to the left is metals. You can see the vast majority of elements that exist are therefore metallic. That takes us to the end of the first video. Thank you for listening and goodbye.